Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 621, Task Scheduler. This is a medium difficulty Leetcode problem. And the problem description, it tells us that we're given an array of CPU tasks, each labeled with a letter from A to Z and a number n. And we're told that each CPU interval can be idle or allow the completion of one task. And tasks can be completed in any order, but there's a constraint. There has to be a gap of at least n intervals between two tasks with the same label. And we want to return the minimum number of CPU intervals required to complete all tasks. So CPU intervals are basically the number of either tasks or idles in our sequence, okay? So in our task sequence, the number of idles or tasks that we need to complete are equal to I, which we can assume is the number of CPU intervals, and we want to return the smallest number of I that we can compute, the minimum number of CPU intervals required to complete all tasks. That is the keyword there, the minimum number of CPU intervals. So let's look at an example. We have 3 A's and 3 B's, and we have n is equal to 2. The output is equal to 8. Why is it 8? Well, there are, because the minimum sequence size is going to be, or the minimum number of CPU intervals is going to be 8, and a possible sequence is A, B idle, A, B idle, and then A and B. It could also be A idle, BA idle, BA, like that. This is just a possible sequence. So we can see that because n is 2, we can't just have A, B, and then A here. That would not work, because there needs to be a gap of at least 2 between each task of the same type. So we have to have an idle. We're forced into adding an idle between each sequence. So how can we actually solve this problem? Well, we can use a greedy approach to solving this problem, and I'm actually gonna copy this example over here, but let's just go with 2 B's, just because it's a slight different case. So how would we solve this? Well, we would pick we'd be greedy. So we're going to want to pick the task which appears the most, and that's A. So we want to create a skeleton for our sequence, right? So we know that we're going to have, of course, 3 A's in our sequence. And we know we're always going to have, this is going to be, each sequence of A is definitely going to appear because it's the biggest number. So each sequence is going to begin with A in our sequence. And then we want to say, what about, we have A, B, and idle. So this is, one sequence. A, B, idle is another sequence, and then A, B is another sequence. So what is going to be the sequence size? Well, it's going to be equal to n, is equal to 2, but we also have an A here already, right? So we want to say it's going to be equal to n plus 1. So n plus 1, that's going to be 3, including A itself. So now we create a skeleton. So you might think, okay, this solves our problem, right? The length of this is equal to 9. That's amazing. We can we can return 9, because that's going to be the length of the number the number of CPU intervals required to complete all tasks. But that is not correct. And the reason it's not correct is, let's actually fill this in. So we're going to have A, B idle, A, B idle, and then we're going to have and then we have 2 idles at the end. We don't need another B because we've used 2 B's. And we've used 3 A's, but why do we have 2 idles at the end? It's because of the way we actually are solving this problem. So we need to define that we want to, calculate this sequence, because this sequence is going to repeat, perfectly fine for all tasks up until the last chunk, up until the last sequence. So let's derive a formula to solve this problem. Well, we can say, max frequency. The max frequency here is going to be 3 minus, I'm going to say minus 1, because remember we want to get all the sequences apart from the last one, times by the length of each sequence, which is going to be equal to 3. So it's going to be equal to, here is 2. Let's say n is 2 here. Let's define that, n is 2. So we're going to say n plus 1 plus, so this gives us everything up to here. We've created our sequence, but we do have a sequence left, and that's going to be just A on its own. So we can just say plus 1, but there is a case in this example over here where we have, B and A appear the same amount of times. They both are drawn when it comes to having the max frequency. So we're going to have a separate variable called max count, which is going to store the number of task types which share the same max frequency. And this is going to basically be our formula. This will serve us to solve this problem. So let's actually get to coding this problem now. I hope this solution made sense. I'll keep this on the top so while we're coding it, we can actually reference what we are doing. So the first thing we want to do is create a frequency counter. We can just use that with a simple Python counter, and we can pass in our tasks. So that's that. We can say the max frequency. So the max frequency is simply going to be equal to the max of frequency dot values. It's going to give us the frequency which appears the most. In this example here, that would be A, but it could be B as well. It will just return A because 3 for A because A comes first. But we know that this can be drawn, so there could be two task types which have the same max frequency, which is why we want a max count, right? We want to be able to count this so we can plug this into our formula. So we want to say it's going to be the sum of 1 for each value in frequency dot values if that value is equal to max frequency. So if that value is equal to max frequency, we'll increment the max count. And then we want to have a result. So our result is going to be, and I didn't mention this earlier, but there is basically an edge case where we have a skeleton that we've created, but there aren't enough tasks to actually fit into that skeleton. So what we want to do instead is take the max of the number of tasks as a fallback, and then we want to put our formula in. So our formula is going to be exactly what we said here. So I can just copy and paste this pseudocode over here, and then return our result. Let's submit our code. Let's check that works. And it does. It passes all 72 test cases for this problem with quite an optimal solution. So again, this problem can be solved. Probably, it's a lot easier to come up with like using a max heap and storing, the biggest, the highest frequency tasks, and then inserting them into a list that we create, and then we can also use we can track a time, so we can increment a time counter, and we can also use a queue, and this queue will say, if we add an A and we have count of 1, so we know that we can add a again after 2, so we'll have a queue for that. And then it's a bit confusing, but you can think of it as more intuitive to come up with. This is less intuitive to come up with, but a lot easier to code. I will be honest. But maybe I might cover solving this with a heap in another video. So I hope this video did make sense. I hope the solution made sense as well, guys. Definitely would recommend playing with both the heap and this, I want to say greedy problem, greedy counting problem. So in terms of time complexity for this problem, it's linear, so it's going to be a big O of n, and space complexity is going to be a big O of 1. Yes, big O of 1 for space as well. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.